we will see collection interface we have seen, and now we will see list interface. So list interface is the child interface of collection. Okay, so in list interface is the child interface of collection. So all the methods that are in collection are also in list by default. All the methods that are in collection is also in list, and there are some more methods, some additional methods that are defined, that are not implemented because this is just an interface, that are defined in the list itself. There are some additional methods. So let's see what are these additional methods in list interface. So collection interface methods are already accessible by list interface, and there are some additional methods also. Let's see what are these additional methods. So we have an add method already in our collection, that if you want to add some objects in our collection, then you can use add method, correct? But in a list, suppose this is a list, okay, in this list you can add, you can simply use the add method. Wherever the available places will be there, it will be added. So if you have an empty list and use an add, and you use an add method, then on the first place it will add, then the second available place it will add, then the third available place it will add. Okay, this will work like this. But what if we want to add on a certain index? What if we want to add on a certain index? Then we cannot use add method. Okay, we have a different method in the list interface for that. Fine. Also you can see these are indexes 0 1 2 3 4. We have an index in list. Okay, 4 and suppose this is also 4. So these two duplicates are actually differentiated with the help of these indexes. Therefore, in the first point when I said that duplicates are allowed, this is the reason that duplicates are allowed. Also these indexes help to maintain the insertion order. These indexes help to maintain the insertion order. Also the duplicates are differentiated with the use of these indexes. Fine. Now let's see some methods in our list interface. So this is a method add int index object o, add object o at specified index. If you want to add an object at a specified index, so we will use this method. Okay, the name is same add, but we have these two parameters. First is an index parameter, that it will take an index at what position do you want to insert the object to. Fine. So the next method is add all. In the next method, if you want to add a whole collection, then you can use an add all. Okay, if you want to add whole collection from this index onward, so you will also specify the index. So we will also specify this index and the collection. So from this index onwards, that we have to add these all elements, then we can use the add all method. Next is a remove. If you want to remove 4, suppose if you want to remove 4, then just pass the index 3. So if we pass the index 3 and remove the element that is present at index 3, so 4 will be removed. Obviously we will see these methods when we will code. Okay, again this is just an interface, so I am reminding you again, only definition, only these methods are defined, not implemented. They will be implemented in the implementation classes. Next is index of method, returns the first occurrence of object o in the list. So if you have two objects, that is 4 and 4, so what index of method will do, if you pass 4 in it, it will return the first occurrence of 4, that is 3. Okay, and the last index of will return 4. It will return the index of the last occurrence of that element. Okay, next is object get. If you want to get index of any of the element, okay, if you pass 2, it will give you 1. If you pass 3, it will give you 2. Fine. Next is iterator. So if you want to access one by one these elements, that iterate through all over our list. If you want to iterate through the list, then we will use the list iterator. Next is object set. If you want to replace an element, for example, here 3, I want to get 5. So what we will simply do here is come here, we will simply set from 3 to 5. Fine. So in this case, we will use the set method. What it will do, it will take the index and the new element. So whatever the element was present inside the index, it will replace that element, it will replace that object from the new object. Fine. So these are the methods that are specific in list interface, and we have also methods that are in collection interface. So now whatever class that will implement the list interface will automatically implement the collection interface, and all the methods should be implemented in that class. Now let's see the classes. So we have collection, list, and the first implementation class that we will see is array list. Since it is an implementation class, so now it has to implement all the methods of list and collection. The methods in these interfaces were just defined, not implemented. Now array list will implement all the methods. It has to implement all the methods in list and collection interface. Array list, this is the first implementation class that we are seeing. So it has to implement the methods that are defined in list interface and collection interface, correct? So let's see some points of array list first. So it is underlying data structure is resizable array or growable array. So the underlying data structure is resizable array or growable array. So array list is based on the data structure array. Insertion order is preserved and duplications are allowed. Okay, duplicates are allowed. Why? Because it's implement list, and list has the definition that insertion order in lists are preserved and duplicates are allowed. So automatically for array list also this point holds true. Next is, since it is an implementation class of list interface, which itself is a child interface of collection interface, so all the methods present in these interfaces are implemented. This I have told you. Okay. Next we will see some constructors of array list. Now we will code, and in coding we will see the constructors. Next we will see some constructors of the array list class. So the first constructor is array list. So this constructor is used to build an empty array list. Now let's see a fun point of this constructor. So when we are creating an object of array list class using the constructor only array list, so it will create an empty list. It will create an empty list. So there is a difference between the size and length. There is some difference between size and length. So if I have my array list, correct, if I have my array list and my elements are present 0, 1, 2 and 3, so the size becomes here 4. So the size becomes here 4. The size of the array list is simply 4. Correct. Now what we will do is, when an empty array list is created, the size is obviously 0. The size is obviously 0, and inside, that is inside of our system, what will happen? It will point to an length 0 array list. It will point to an length 0 array list. But when we insert a single element, okay, this array list object is created, no issue. This size is 0. It is pointing to an empty array list. That is also not an issue. But when a first object is inserted, for example, we are calling an add function and we are adding 2 in it, what will happen? This object now will not point to an length 0 list, but it will point to a default capacity. That is, now I am using the word capacity, the default capacity of 10. The default capacity of 10. So here we will have 10. So here we will have 10 storage spaces. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 and 10. Okay, 7, 8, 9 and 10. Okay, sorry, only 9. 0 to 9 becomes 10. Fine. So this is how it happens. So when I use this array list, so at the beginning size is 0, the length is 0, but as soon as I add just a single element, it becomes, this capacity becomes by default 10. The capacity becomes by default 10, and 0 and 2 here is added at the index 0. Fine. Now for example, I have completed it. So I have added all the elements 2, 3, 4, 5, 9, 10, 11, 13 and 12. Okay, I have added all the elements. Now array list is growable in nature. Array list is growable in nature. So arrays are not growable in nature, but the array list is growable in nature. So even if I have declared that even if the capacity was 10, it can grow to 11, 12, 13, any point. Okay, now even if I want to add more elements, for example, I want to add 40. So what will happen? My array list is an object, so obviously I will have a reference variable. For example, al is the reference variable, so al will be pointing here. What will happen? A new array list will be created inside my memory. A new array list will be created inside my memory with some capacity, okay, and these elements will be copied into this new array list. Okay, and when these elements are copied, so this last element will be copied, and then after this last element 40 will be inserted. This is how the growable nature of array list is implemented. Okay, so this is not performance. So this takes a toll on our performance, obviously, because we are copying all these elements from one list to another list. So if we have thousands of elements in one list, so we are copying thousands of elements just to add one more. Okay, so this is a disadvantage, obviously, but this is how it is implemented. Okay, what will be the new capacity? Now we want to know. The default capacity was 10. So what is the new capacity? So the new capacity formula is very simple. That is, the capacity equals to the current capacity into 3 by 2 plus 1. Into 3 by 2 plus 1. So the current capacity is 10. So 10 into 3 by 2 plus 1, which is nothing but 16. So the new capacity of this array list will become 16. Now if I want to add another, so again the current capacity now is 16. So 16 into 3 by 2 plus 1. So I will get 2. 8, 8 is 24 and 1 is 25. So the new capacity will become 25. So this is the formula. Just take care. This is just to So this is just explained if some interviewer asked what is the current capacity and what is the growable nature, how the new capacity will be calculated. So this is how a new capacity will be calculated. This is the formula. Okay, so this was just for your information. Now we have seen the first constructor. So this was the default capacity of 10. So in the next constructor we can specify the capacity. We can, when creating object, we can specify the capacity that we want the array list of having this much capacity. So we will use this in the program. Now we are going to do a program. The last is array list of collection C. If we want to add a collection, the whole collection into an array list. Okay, this is used for interconversion. So if I have a linked list and if I want to convert a linked list into an array list, we will use this constructor. So now let's do some coding. So now in this program we will be using our array list class. We will be using the methods of the list interface and the collection interface for our program. Okay, we will add, remove, delete, we will do all sort of stuffs here. So first let me define a capacity. So int n equals to 5. So the initial capacity that I am defining for my array list is nothing but 5. Okay, no, not an issue here. Since I am defining a capacity, I will be using a constructor that defines capacity. So array list, I will pass my integer. So what is the integer here? Integer is simply and type parameter. So generics, the concept of generics. Now array list equals to, this is my reference variable. I will create an object using the constructor array list and I will pass my capacity in it. Okay, this is was the second constructor that I have told you. Okay, for example, I want to input 5 values. So int I equal to 0, I less than n, I plus plus, and I will simply use the add function. So this is the first function that I am using. I will be calling it with the help of our reference variable array list dot add, and I will add simply I. So for 0 it will add 0, for when I equal to 1 it will add 1, when I equal to 2 it will add 2, and at the end I will simply print s out array list. Fine, not an issue. Now let's just run and see if my elements are inserted into the array list or not. So this is what the add method okay, that we have seen in the collection interface. So this add method is what we have seen in the collection interface, not on the list interface. We will also use the add method of list interface. Okay, so as you can see 0 1 2 3 4 is added in my array list. So the next method we will be seeing now is remove. So array remove, array list remove, and the index. So I want to remove the element at index 2. So what is it? What is the element at my index 2 is 0 1 and 2, so it is 2. So now when I print, I will simply print array list. So let's see, after remove, after element at index 2 is removed. Okay, so this will print my array list. Fine, let's see. So after element at index 2 is removed and simply array list. If I run it, I will simply get 0 1 3 and 4. Fine. So after remove, I will see my next method. So as you can see, after element at index 2 is removed, my array list becomes 0 1 3 and 4. Simple. So now let's see the next method. So this was what? A remove method. So this remove method was also from which interface? It was also from the collection interface, not list interface. Okay, now let's see the next one. So the next one that we are going to see is add method, but not of the collection interface, but of our list interface. So array list dot add. Now I have deleted an object from index 2, so I will add at index 2 and I will add, for example, 10. Okay, now I will again print it. So after adding at index 2, my array list becomes, it's very simple, it's really simple and it's really easy. See, it's how easy it is to add elements into an array list, or to add an element at a specific index into an array list. Okay, so if you are using what say a simple array, we have to write the whole code that is written inside these methods, but using array list we don't have to do all sort of these stuffs. Therefore collections makes the programmers lazy. It becomes very easy for programmer. So as you can see, at index 2 10 is inserted now. Okay, so obviously at the backend, these add and this remove are all implemented using the functions that we have to write if we use arrays. Okay, so if I want to input 10 here at index 2, I have to shift 3 and 4. I have to shift 3 and 4. Also in shift, because the initial capacity was 5, I don't have to grow. But if I add one more, the capacity is just 5. So the list has to grow. So what I have explained before, how it will grow, it will copy all the elements into a new list then array list will now start pointing to that new list. The capacity will be increased, multiplied by 3 by 2 plus 1. So this everything will occur. Okay, so at the back end everything is happening, but for the programmer it becomes so easy. So this is the concept of collections. So for seeing the next method, let me add a duplicate element. So for example, I am adding 4. I am adding 4 at index 1. So let me add a 4 at index 1. So array list dot add at index 1 the object 4. Okay, this is what I am doing. Now let me see if it is added or not. So after adding 4, what I will simply do, I will print my list. Okay, array list. Now the program runs. So after adding 4, so as you can see at index 1, 4 is added. Now let's use the index of function. Okay, so system.out.println, what I am doing, the first index of 4, so first occurrence of 4. So how you will use the first occurrence? So simply array list dot index of. So index of will provide me the first occurrence of the repeated element, that is 4. Okay, and if I want the last occurrence, then I will use the last index of method that we will use now. So first index is 4, is 1 simply. So 4 is at index 1. Now if you want the last index, so s out last index of 4, last index of repeating element 4, duplicated element 4, that will be simply array list, that is the reference variable, dot last index of 4. So when I print this, the object is 4, the last index is nothing but 0, 1, 2, 3, 4 and 5. So answer will simply print the last index of this p is of 5. Okay, this corrected here. So next method that we will be using now after the index of and the last index of is get. So if I want not the last index or not the first index but a simple index, okay, I want to get an index of 1 or I want to get an index of 3 or 10. So the next method we are going to see is the get method, and what get does, it gets me the element at a certain index. Fine. So system.out, I want the element at index 4. So element at index of 4 is, let's see, plus array list dot get the element at index 4. Okay, now let's run it and let's see the output. What is the output of this get function, get method? So the index 4 element is nothing but 3. As you can see, 0, 1, 2, 3 and 4. So at the 4 index I will have the element 3, so it returns me an element 3. So this was the get method. So we have seen many methods. We have seen add, we have seen remove, that are for collections. Okay, the collection interface. We have seen the add method of list interface. We have seen index of method. We have seen the last index of method. We have seen the get method. We can also use the empty method. So we have s out, empty method was in collection interface. So s out is empty, is my collection, is my array list empty? So is it true or false? So it returns a boolean value, that is a true or a false. So array list dot is empty, so it is asking a question, is it empty or not? If it is empty, it will return true. If it is not empty, it will return false. So is my array list empty or not? Let's just run it. So is empty is false, because my array list has element, therefore is empty is simply false. The next method that we are going to see now is size. So let's do the size. It's very simple. So the size of my array list, size of array list. What is the size of the array list? Let's see. So array list dot size. So see, these all methods, what happens is when we are using a standard data structure, we have to create all these methods. We have to implement this by our own to get the size, to see if it is empty or not, to get the first index, to get the last index, to get any element of a certain index. So the size is simply 6. So we have to implement this, but these methods are already implemented in the array list class and are defined in our interface list and collection. And whatever the class that is implementing list has to implement also the methods of collection. Okay, so all these methods are not only in array list but also in linked list, because we also implement list, and that is our next topic. Okay, then we can see contain also. This is also returns true or false. I want to see if 10 is in array list or not. 10 is in array list or not. If 10 is in array list, it will print me a true. If it is not, it will print me a simple false. So array list dot contains object 10. Okay, now let's see. If 10 is in the array list, it will return me a true. If 10 is not in the array list, it will simply return me a false. So since 10 is in the array list, as you can see, so it returns me a true. So these are few of the methods. Okay, we can also use the iterator method, but I will show you the iteration when I will show you the iteration method during the cursors. Fine. So this was a simple example of array list class. We have seen many methods. There are other methods also. So the next method is set. We can also see set now. So if I want to replace an element at a particular index, so array list dot set, and at an index 2 I want to replace whatever element is at an index 2 from the element 17. Okay, so 17 now should be present at an index 2 and it should replace the current element. So s out dot an array list. So let's see if it replaces or not. So my current element is 0, 1 and 2 is 1. So now in the place of 1 I should get 17. I should simply get 17. Okay, so as you can see, in the place of 1 I got 17. So this was a set method. So we have seen many methods. So there are other methods also. Fine, but these are the most commonly used methods, and there is iteration that we will see in cursor topic.